Hey everybody, I hope you're doing well. We're going to start today's lesson a little different today. Instead of just hopping into a title and getting right after it, I want to kind of review what we talked about in the previous lesson when we were talking about independent and dependent variables. So look at this very simple situation I have in front of you. Granola bars are sold in boxes of 12. I want to identify the independent and dependent variable of this scenario. So if you could grab a sheet of paper and work through this with me. First thing we want to do, if you remember from our previous lesson, is identify the quantities. What values can be measured by a number in this scenario? And in this case, we can measure boxes with a number and total granola bars with a number. Now we need to determine the independent and the dependent variable. Do the number of granola bars I get to take home depend on how many boxes I purchase? Or do the number of boxes I take home depend on how many granola bars I purchase? What do I have control over? Do I decide how many granola bars I can buy? Or do I decide how many boxes I can purchase? Boxes is the independent variable because I can choose how many boxes to put in my shopping cart. I can't just purchase 4 granola bars or 7 granola bars. I have to buy them in boxes. So I have control over the number of boxes, which makes it the independent variable. Once I decide how many boxes to put in my cart, the outcome is total granola bars I get to take home. Now I'm going to represent our independent variable boxes with the variable B and our dependent variable, the outcome, granola bars, with a G. And I want to use that information to create an equation representing the relationship here. So when you're writing an equation based on the relationship between an independent and a dependent variable, the first thing you do is always take your dependent variable and start your equation with it. The dependent variable will always be all by itself on one side of the equation. So I have my dependent variable G because the granola is depending on how many boxes I purchase. And I'm going to bring down my equal sign because my dependent variable is always the only thing on one side of the equation. Now, on the other side of the equation, I need to take my independent variable and determine what mathematical calculation is occurring with this independent variable. Oops, excuse me, bumped the camera. All right, there we go. Sorry about that. What I was saying is, on the right side of our equation, we need to determine what mathematical calculation is occurring with my independent variable in order to get the outcome that is the dependent variable. In this case, mathematically, what are we doing to the number of granola boxes to calculate total granola bars? Well, from our problem up here, I know that every box has 12 granola bars in it. So one box would have 12 granola bars. Another box would be another 12. A third box would be another 12 granola bars. So every box I buy is another 12. Well, repeatedly adding 12 over and over again, that is multiplication by 12. So I'm going to take the number of boxes I purchase and I'm going to multiply it by 12. So the number of boxes times 12 will give me total granola bars. Now I can use that equation to complete a table of values. In a function table, your first column is always your independent variable because it is the input of the function. So total boxes goes here. The outcome, the output, the answer, the result, that's always your dependent variable. So G, granola bars here. Well, this one means one box of granola bars. If I purchase one box, if I take 1 and plug it into B, 1 times 12 is 12. So one box would get me 12 granola bars. My next option is 4 boxes. If I purchase 4 boxes, I can take this 4 and plug it into the variable B. 4 times 12, I would get 48 granola bars. Next in the table is 7 boxes. If I purchase 7 boxes, how many granola bars will I get? Plugging a 7 into B, 7 times 12 is 84. So 7 boxes would yield 84 granola bars. And finally, 10 boxes, 10 into B, 10 times 12 10 boxes would get me 120 granola bars. This right here is what today's lesson is all about. We are learning how to create function tables. So if you want to record in your notebooks, here's some definitions for you. First off, a function. It's a relationship that assigns exactly one output value to each input value. And we just saw that on the previous example with the granola bars. If I buy one box, I get 12 bars. If I buy 7 boxes, I get 84 bars. For every independent variable value, there is only one possible outcome. We're going to record all of those values in a function table. It's a table of ordered pairs that are related following a rule. That rule being the equation, the calculation that took place with that independent variable. So we essentially see the relationship between the independent and the dependent variable in these function tables. All right, so let's go ahead and take a look at our first example. We are just completing function tables. So here is our function. Here is our linear equation, y equals x plus 7. Now, the independent variable will always be the variable on the side of the equation that features the calculation. So because we are adding 7 on the right side with x, x is our independent variable. The independent variable is always the input. So I'm going to place it in the first column of my table. The dependent variable is always my outcome. It will always be all by itself on one side of the equation because it depends on the calculation taking place on the other side. Because the dependent variable is also the output of the function, we're going to write it or label the second column with it. Now we just need to plug in values to get our outcomes. Our first input value for x is a 0. So I'm going to take that 0 and I'm going to plug it into x. Instead of x plus 7, I'm going to get 0 plus 7. And then I'm just going to perform that calculation. 0 plus 7 is 7. So when x equals 0, y will equal 7. And we're going to continue that process with our next input value, plugging a 1 into x. Instead of x plus 7, I would have 1 plus 7. 1 plus 7 is 8. So when x has a value of 1, y will have a value of 8. Plugging a 2 in next, 2 into x. Instead of x plus 7, I'll get 2 plus 7. 2 plus 7 is 9. When x equals 2, y will equal 9. And then finally we have a 3. Plugging it into x, instead of x plus 7, 3 plus 7. We perform the calculation. 3 plus 7 is 10. When x equals 3, y equals 10. And so we just completed a function table. Okay, here's another one to try out. Hopefully you have a sheet of paper and you're following along with me and trying it out on your own. Our function p equals 1/2 n minus 6, and we have a table below to complete the values. First off, let's identify our independent variable to label over our first column. The independent variable is on the side of the equation where the calculation is taking place. All of the math is happening on the right, and the variable n is featured there. So n is my input. It is the independent variable. Place it over the first column of your function table. The dependent variable is always by itself on one side of the equation because it depends on the calculation. P is by itself. P is the outcome. P gets labeled over our second column. Our first input value we have is a 12. So I'm going to take 12 and I'm going to plug it into n. Remember, the 1/2 is touching n means it is being multiplied. So instead of 1/2 times n, I'm going to do 1/2 times 12 minus 6. Multiple operations here. Make sure you're following the order of operations. We are going to do multiplication first. 1/2 times 12 is 6. I'm going to bring down my minus 6. And then 6 minus 6 is 0. So when n equals 12, p will equal 0. Next, I'm going to plug in an 18 for our independent variable n. So 1/2 times, in place of n, I'm putting an 18 minus 6. And now we just simplify that expression. 1/2 times 18 is 9. 9 minus 6 gives us 3. When n equals 18, p equals 3. Sometimes you'll be given a blank table to complete with your function. In that case, you get to choose any input values you want. Be strategic about it, though. think any value that I plug into n is going to be multiplied by 1/2. So you want to choose a value that is easy to work with. Anytime the coefficient on an independent variable is a fraction, I recommend you choose multiples of the denominator. That way you will always end with a whole number. So because my denominator is a 2, choose a multiple of 2. Any multiple of 2 will do fine. I'm going to choose 20. So if I plug a 20 into 1/2, or excuse me, into n, I'm going to do 1/2 times 20 minus 6. 1/2 times 20 is 10, and 10 minus 6 is 4. And then choose any other value you want. I'm going to choose, let's choose 30. Plugging a 30 into n, we're doing 1/2 times 30 minus 6. 1/2 times 30 is 15, and then we do 15 minus 6, and you get a final result of 9. So when n equals 30, p will equal 9. Okay, on your screen, I have two functions that I want you to complete the table for. T equals 2h minus 1. Complete this table over here with it. And then over here, y equals 1/4 x. Complete this table. You will get to choose your own input values for the final two on that one. Once you've completed both function tables, begin playing the video again to check your work to see how you did. Okay, boys and girls, let's check your work. First off, h is our independent variable, so we place it over the first column. T is the output. It is the dependent variable. Place it over your second column. Next, we're going to plug an 8 into h. 2 times 8 is 16, and 16 minus 1 gives us an output of 15. Our next input value is 11. 11 into h. 2 times 11 is 22, and 22 minus 1 is 21. 14 goes into h. 2 times 14 is 28. 28 minus 1 is 27. And then finally, 17 into h. 2 times 17 is 34. 34 minus 1 is 33. So that completes the table for the function t equals 2h minus 1. Next, we had y equals 1/4 x. X is the input. It's the independent variable. Y is the output. It is the dependent variable. Plugging a 0 into x. 1/4 times 0 is 0. Substituting a 4 into x. 1/4 times 4 is 1. Now we get to choose any values you want. If you remember from our previous example, choose multiples of the denominator. So I'm going to choose 8 next because it is a multiple of 4. 1/4 times 8 is 2. And then I will choose 12 as another multiple of 4. 1/4 times 12 is 3. Boys and girls, make sure you complete the independent practice assignment for function tables. Take a picture of your work and upload that file for submission. I'll see you guys next time.